Hey, here's the first review video for our upcoming exam 3. First question is a simple interest question, and we'll use this formula right here. Amount paid is equal to principal times, in parentheses, 1 plus the interest rate times the time in years. And so in this scenario, we've borrowed $1,000. From Guido, who is probably a sketchy character, and he's giving you the lowest annual interest rate he's ever offered, but he wants to be repaid in 6 months. Now, what is 6 months in terms of time? 6 months is a half a year, so we have a half in here for our t. Now, he can't calculate compound interest, so he'll be charging simple interest. That's probably not the only reason he's charging simple interest, but anyway, we want to know what rate he's charging if you have to repay $1,250 at the end of 6 months. Well, the amount paid then is $1,250, so we put that in here, and the principal is what we borrowed, so we put that in here, and that leaves us with only one variable, the one that's being asked for, the interest rate. And so to isolate it and solve for it, we multiply the principal, 1,000, through both terms inside the parentheses. 1,000 times 1 is 1,000. 1,000 times r times 1/2 is right here. And, of course, 1,000 times 1/2 is 500, so this is 500 times the rate. And we have then subtracted the 1,000 from both sides here, which clears it from the right side and subtracts it from the left, which leaves 250. 250 is equal to 500 times r. We divide both sides of the equation by 500, and that gives us 0.5, which is a decimal, and converting to a percent, we move the decimal 2 places, and that's 50%. So that's the rate that our good buddy Guido is charging. Now, number 2 is a compounding interest problem, and we're compounding periodically, and those periods are months, so we're compounding monthly. And we'll use this formula, A equals P times the quantity 1 plus R over M, and that quantity is raised to M times T. Remember, M is the number of compounding periods per year. The question asks how much will be in this account. In other words, what's it going to end up being after 4 years. So this is an investment. We want to know what our investment's going to be worth in 4 years. Well, excuse me, our principal P is 5,000. It's spelled out very clearly right there, so we put that here. And the rate is 5%, so we convert that to a decimal, 0.05. R goes in the numerator here, and so that's 0.05. We're compounding monthly, it says right here, and so that's the number of compounding periods per year. There are 12 months in a year, so that's 12 here. And then in the exponent, 12 times the number of years, which is 4, and that's given here. And so all we have to do then is to enter this in correctly in our calculators. And to do that, you might start with some parentheses around the 1 plus 0.05 over 12, and then use the little caret or the EXP key, depending upon what kind of calculator you have. And in the exponent, enter 48. And then once you have that answer, you can multiply it by 5,000. That's just one way to do it, but whatever set of keystrokes you use with these figures, with this formula, that gets you to $6,104.48, those are the strokes that you will probably want to have on your note sheet. And of course, don't put 5,000 and 0.05 and 12 and whatnot on your note sheet. Put the abstract here. Put the formula with the letters. So make sure you've got that set and put that on your notes, and you should be able to get this question right easily for full credit. Then we're also going to need to calculate how much is in this account if we compound the interest continuously. It's going to be more, not a whole lot more, but it's going to be more. But it's a simpler formula. We enter 5,000, the principal, here, and we multiply times e raised to the 0.05, the rate right here, times the time. And if we enter that in correctly, then we'll have a figure of $6,107.01. And as you can see in section 3.2, there are other exercises, I believe they're on your practice, that you can go through to make sure you're getting those answers as well, because they're odd and the answers are in the back of the book. Now question 3 asks us to determine the APY, the annual percentage yield for money that's invested at 2.99% compounded continuously, and the APY for a 3% interest compounded monthly. What's the better rate? Well, the APY formula for continuous compounding is given here. It's e to the r minus 1. And so we plug in 0.0299 because that's the decimal equivalent of 2.99%. We put that up here in the exponent. We raise e to that figure and then subtract 1, and that gives us approximately 0.03035. We carry it this far because that's how many decimals we need to carry it to distinguish between it and the other rate that we get for the monthly compounding. So here's our formula for APY when we compound monthly. That's 1 plus the rate divided by the number of compounding periods per year, raised to the number of compounding periods per year, and then from that quantity we subtract 1, and you can see that worked out here. And the APY we end up with here is 0.03042. You may not have to carry this out this far for the actual exam question, or you may have to carry it out farther, but what you need to do is round it, or carry the decimal out just as far as you need to tell the difference between this value and this. If we rounded this value to this place right here, it would be 0.0304, because this is a 5 and that raises this 3 to a 4. And if we rounded this value to the 4th decimal place, then that would also be 0.0304, because the 2 would drop off and not raise this 4 to 5. And so they would both be 0.0304, and you wouldn't know which one is better, which one is more, which one is less. So carrying it that one extra place tells us that this is the better rate. So with the higher APY, 3% compounded monthly is the better rate. Yes, that's the better rate. That is the better rate, because there's a 4 here, not a 3. Okay. Now this question 4 asks us how long it's going to take money to double if it's invested at 6% compounded quarterly. Well, the number of compounding periods per year is 4, because there are 4 quarters per year. And here's our periodic compounding again, interest compounded periodically. And no matter what amount is invested, no matter what the principal is, the amount that we're looking to earn is double that, twice that. So P is the principal, the amount earned is 2P. And then when we divide both sides of this equation by P or multiply by 1 over P, the P's cancel and we wind up with 2 equals this figure on the right side. 0.06, which is our rate, converted to a decimal, divided by 4 is 0.015. You add that to 1 and you have 1.015. So that's convenient. It's an exact figure. You don't have to round or carry it out a lot of places. And the number of compounding periods per year again is 4, so that's 4t here in the exponent. And so we end up with 2 is equal to the quantity 1.015 raised to the 4t. Then we use the properties of logarithms. Doesn't matter if this is natural log or the common log, we just take the same log of both sides. And we use the power property to bring the 4t around the front of this logarithm. And so we have natural log of 2 is equal to 4t times the natural log of 1.015. Then we're trying to isolate the t, so we divide everything on, or we divide both sides of this equation by everything that's not t. Well, 4 times 1.015 is everything that's not t. And so we have on the left side natural log of 2 divided by 4 times the natural log of 1.015. Those values cancel on the right, and so we're left with t is equal to this value here, whatever it is. We enter it into our calculators and we come up with approximately 11.64. So that's about how much time? 11.64 years. And now question 5 asks us how much our payments should be if the future value of an annuity is $2,500. The interest rate per compounding period is 0.08 and the number of compounding periods is 10. So this very explicitly tells you what values to place into every variable except the one that you're looking for, which is how much your payments should be. For number 5, we use this formula here. Payment equals future value times I, which is the rate per compounding period. So that's already given. You don't have to divide as you did in this question, in question 4. So that's already given. And so we fill all these values in. 2,500 is the future value, goes right here. I is 0.08, goes right here. If you add 0.08 to 1, you get 1.08. That's then raised to the 10th power because the total number of compounding periods is 10. And we subtract 1. And so when you enter this into your calculator, you're going to need a parenthesis around the entire denominator. Because if you fail to do that, then this minus 1 is going to throw your calculations way off. So if we do enter this all in correctly, we will come up with a payment of 172.57. And whereas the earlier questions were from section 3.1 and 3.2, this question is in section 3.3, and again you can find some more sample questions that you can practice on and make sure that your answers are matching up with what you're getting in the back of the book. So there's the first half of the exam, and